Hello everyone, welcome back to the AWS Cloud Engineer Essentials series. My name is Dheeraj and today we are going to cover the essentials of AWS Lambda, which is one of the most powerful serverless services on AWS. So today we are going to learn what Lambda is, how it works behind the scenes, how it's priced, and how to configure it for real world use cases. By the end of this video, you will understand how to build event-driven auto-scaling application without managing any servers. So let's start by understanding what AWS Lambda is exactly. So AWS Lambda is a serverless compute service, which means you don't have to manage or provision any servers. AWS runs your code for you so you can focus purely on your logic instead of worrying about infrastructure. Lambda is event driven, meaning your code runs only when it is triggered. Otherwise, it is not going to run. Like when a file is uploaded to S3, an endpoint API endpoint is called, or a scheduled event occurs. For example, suppose if you have a Lambda which is already in place, you can invoke it in multiple ways. The one of the way is you can invoke it by using S3 trigger. You can invoke it by using API endpoint, or you can invoke it by scheduling the event. For example, suppose if you have to run that Lambda at every 5 p.m. of the day, you can schedule that too. It's also cost efficient because you pay only for the compute time your code actually uses, measured down to the milliseconds. Another big advantage is automatic scaling. Whether you get one request or 10,000 at once, AWS Lambda scales instantly to handle the load. Common use cases includes API backends, file processing, scheduled tasks, and real-time data transformations. In short, AWS Lambda lets you build powerful, scalable applications without ever managing a single server. You don't have to create any EC2. You can run your workloads on AWS Lambda. Now, let's see what really happens behind the scenes when AWS Lambda function runs. Lambda function uses a container-based execution model. So every time your function is triggered, AWS runs it inside a secure, isolated container with the runtime and dependencies that you are going to define. What does that mean? So what is runtime? Runtime means is your runtime Node.js, Python, or some other programming language that could be a runtime. Now dependencies. If there is any dependencies that needs to be installed for your code to run, that is what you attach to your Lambda function. So this runs while this is attached while your Lambda function is running. And when the function runs for the first time, AWS needs to create a new container. So this is called a cold start. It usually takes 1 to 2 seconds because the environment is being initialized. For the next few requests, Lambda can reuse the same container known as warm start, which runs almost instantly in just a few milliseconds. So Lambda also maintains an execution context, meaning certain parts of the environment like database connections or cached data can persist between invocation. This helps improve performance. When multiple requests arrive at once, Lambda automatically creates separate container instances, each handling one request, allowing massive parallel execution without any manual scaling. So in short, AWS Lambda efficiently manages containers behind the scenes so your code always run fast, secure, and independently of each trigger. Now let's understand how AWS Lambda pricing works and why it's one of the most cost-efficient services on AWS. So Lambda has a permanent free tier which gives you 1 million requests and 40,000 GB seconds of compute time per month. That is completely free forever. But these things keeps on changing, so it's always best to check this from the official website. After that, the request charges are very minimal, just 0.20 per 1 million request. So you also pay for the compute time, which depends on the amount of memory that you have allocated to your function and how long the Lambda is going to run. So this is measured in GB seconds. So for example, if you allocate 128 MB of memory and your function runs for 200 milliseconds, that equals to 0.025 GB per second per invocation. That is a very tiny fraction of a cent. So to optimize cost, always right size your memory, reduce execution time, and write efficient code. With careful design, AWS Lambda can handle large scale workloads at an extremely low cost, often just few dollars a month. Now let's look at the basic structure of AWS Lambda, how it actually works behind the scene. So these are the basic structure like Lambda handler function, event object, that is the triggers, context object, that is the runtime, return value, and the Python runtime that Lambda supports. Now, instead of showing you this from the PPT itself, let's keep it in a mixed mode where I can show you on the console too. So if I click on Lambda over here and open the Lambda service, once it is open, so whenever you go ahead and click on create Lambda, so these are the basic things which are going to come into picture. Okay. So if I click on create a function, so while you do create a function at that time, it is not showing that in details. So what I can do is I can click on functions, Lambda. Okay, so the function is not in this region. I will go to another region. Over here, I will get a lot of functions. Okay, I have 18 Lambda functions over here. So let me open Lambda function named demo. Okay, so now let's talk about what exactly I was showing. So there is a handler function. What exactly the handler function is? So every Lambda starts with the handler function, which is the entry point of your code. In Python, it's usually defined as Lambda underscore handler that you can see over here, Lambda underscore handler. Now, the event object carries the data passed from the trigger. For example, if I am going to trigger an API request payload or details of a file upload to a S3, so that is how you have an event object that contains the data from the trigger. So for example, suppose if you are performing, suppose this is a Lambda, okay, there is one request coming from API gateway. But if that API gateway is coming from one point to another by carrying some data, that is known as your event object. And the return value, you can send a return response once your Lambda has been triggered. While you send your return response, in that way, you can also send the value goes in a JSON format and it has been captured by the API gateway if it has been invoked by API gateway, or once the output you will see once we run below, when we do it a test, at that time also you will see what is the return object which is being returned by the method or function that you have written over here, which is having an event as well as the context as the argument of that specific function. Now, there are different types of Python runtime that are supported. So if you go ahead and create a new Lambda, I will go ahead and create a new Lambda. So at the time of creation of new Lambda, if I click on runtime, so this is the runtime. So in this runtime, you will see that these are the runtimes which are supported. So over here, you can see Python support is 3.9 to 3.12. So you can select any one of them. Suppose if you want to go with 3.12, so this is what a runtime is known as. So that is what a Python runtime is. But it is not only the Python runtime. If you want, you can select some other runtime also, like Node.js, Ruby, Java, .NET, based on the requirement that you have for running your workload. Now let's talk about how permissions work in AWS Lambda, because security and access control are just as important as your code. So every Lambda function runs using an execution role. So if you see over here, see, it is having default execution role. What this default execution role says, choose a role that defines the permission of your function, or you can create your own. But by default, when you create the Lambda with an execution role, the permissions to upload Amazon CloudWatch logs are being added, as well as if you have any triggers with this like S3 or something, it will have permission for that specific service also to be reached. So every Lambda function runs using an execution role, which is an IAM role that Lambda assumes to access other services, that is AWS services, on your behalf. So by default, Lambda needs basic permissions to write logs to Amazon CloudWatch, as I showed you. Depending on your use case, you can attach additional permissions too. So as I said, the default IAM role which it is going to create, you can add additional permissions to also for that. Like for example, if you want to access S3 for reading files, or DynamoDB for storing data, or SNS for sending notifications, so you can add those permissions to your role. Always follow principle of least privilege, meaning your function should only have the exact permission which is being required, nothing more than that. You can also use resource-based policies to control who or what can invoke your Lambda function, ensuring it's only triggered by trusted sources. In short, IAM roles and policies define what your Lambda function can do and who can interact with it, keeping your environment secure and well controlled. Now let's talk about configuration, that is memory, timeout, and environment. So first, memory allocation. You can choose anywhere between 128 MB to 10 GB of memory. The more memory you allocate, the more CPU power your function automatically gets when your Lambda is being triggered or when you run the Lambda. Next is the timeout. This sets the maximum execution time for your function. Suppose right now I'm clicking on run. So my program, my code is running and it is taking 2 minutes, 5 minutes, 10 minutes, 15 minutes. So this is the execution time. So the max execution time that a Lambda can run is only 15 minutes. If your code is running more than 15 minutes, it is going to time out. So environment variables lets you store configuration data such as API keys, database names, or bucket paths. So if I go over here to your Lambda functions, which has already been created. So over here, you will see configuration. Inside configuration, so these are the general configurations that you defined. If I click on edit, you will see you can define the memory, you can define the ephemeral storage, you can define the timeout. So if I go ahead with the timeout, you can add the timeout over here, whatever you want, in seconds or in minutes, whatever, based on your requirement. Then you can also create a new role or attach a new policy and replace it with the existing role. So these are the configuration that we are right now talking about, like memory allocation, timeout. Now, as I was talking about environment variables, you can actually also add environment variables. Right now, you are not able to see over here because I have not added, but you can add environment variables too. But environment variable would be available over here on the left hand side. So you click on environment variables over here. Suppose if you want to perform any operation on database which requires a password, or any operation which requires authentication or API key, at that time you can store those values in your Lambda configuration, and this Lambda configuration can use it later. So this lets you store the configuration, and then when required you can use it, and these are encrypted at rest, keeping your sensitive information secure while allowing easy updates without changing your code. Lambda. So now Lambda also provides ephemeral storage available as temporary directory. It offers up to 512 MB by default, which can be expanded up to 10 GB. So, and it is perfect for your temporary file storage during execution. Many a times you have some dependency file or some dependency package which is not available, that can be fetched online. It might be your custom package or your custom dependency. At that time, you can keep it attached as a layer to your specific Lambda function, which would be stored in your ephemeral storage. And finally, Lambda layers lets you share common libraries or dependencies across multiple functions. So you don't have to package the same code repeatedly. For example, I have 4 different Lambda functions. So if I have to perform an operation on CRUD operation on DynamoDB, one operation would be get, another would be post, third would be delete, and fourth would be get list. So these are going to be 4 different Lambdas. Now to perform this operation to DynamoDB, at that time, if I have any dependency of package, every time I don't have to attach again and again to all the lambdas. Instead, I can create one lambda layer, uh, and you can go ahead on lambda, and over here you can click on layers. Inside the layers, you can create a layer, and then once the layer is created, you can associate it to multiple different lambdas. So it has one to many relationship. That is how you can use layers. Now, these configuration options together help you fine tune your Lambda performance, cost, and maintainability. Now, let's look what can trigger your AWS Lambda function, because Lambda is designed to react to events automatically. First is API gateway, which can trigger Lambda when an HTTP or REST API request is made, making it perfect for serverless APIs. Second is Amazon S3, which can trigger your function whenever an object is uploaded or deleted within a bucket, which is great for use cases like image processing or ETL pipelines. Third is DynamoDB streams, which allows Lambda to respond in real time to database changes. For example, when an item is added or updated. So if you have a table, user table, in that if any user data is updated, like a user ID or username, at that time you can trigger a Lambda to perform any specific operation. Next is Amazon EventBridge. Previously, it was known as CloudWatch Events. Now it is known as Amazon EventBridge, and you can run your Lambda on a schedule base. As I said in my first slide, that you can also invoke your Lambda in a schedule based manner. It's ideal for your cron jobs or periodic tasks that you have run once a day or twice a day. And finally, SNS and SQS can trigger Lambda for message-driven processing, allowing your function to handle notifications or queue messages automatically. So together, these event sources make AWS Lambda a powerful event-driven compute platform that can integrate seamlessly with almost any AWS service. Now, we are going to go ahead and create our first Lambda function. So as part of this, I will guide you step by step how we can go ahead and create our first Lambda function. So what you can do is, first you can go ahead and click on Lambda. Once you click on Lambda, you will come inside this console. Inside this console, you have to click on create function. Once you click on create function, there are three different options. First is author from scratch. That means you are making all the permissions by yourself. Second is use a blueprint. So this is a blueprint where you have multiple options which are already available in different runtimes. So some are Node.js, some are Python. So see, over here it says, this blueprint says that an Amazon S3 trigger that retrieves metadata from object that has been updated. That means if there is any S3 object which has been updated in the S3 bucket, for that specific thing, this is the Lambda. See, for that the code is also available. So you can use this specific blueprint. When you use it, it actually gives you the entire automation itself. So when I use this blueprint, you can see it has added a Lambda function code, which is in Python by using Python Boto3 library over here. Then it has also configured the S3 trigger for you. Means it has associated but not configured. The configuration you will have to provide by providing the buckets and everything. So all the things it has already pre-configured for you. You can just have to go ahead and provide the exact values, like with which AWS S3 bucket you have to associate it. So this is how you can use a blueprint. Now, if you have your custom container images, at that time you can use the third option, where you can select a container image that can be deployed to your function while your Lambda is being invoked. So these are the three ways by using which you can create your Lambda. Now for this tutorial, we will author from scratch, and I would say cloud engineer demo, and over here I will select Python 3.12. Once I select Python 3.12, now for permission, you can see that by default Lambda will create an execution role. So I will keep the execution role as it is. I am right now not adding any permissions. If required, we will add it later. Now, this is the Lambda. Additional configurations, what is available, you can actually, if you want to connect your function, that is the Lambda function, to a VPC, so that you can make access to private resources during invocation. For example, suppose if you have created a private VPC, inside that private VPC you have an RDS. So to make communication for this internal private resources that you have, or secured resources, you can associate your specific Lambda to a VPC under which these resources lie as a private VPC. And apart from that, you can also go ahead and use code signing, encryption with AMS key, and tags. So tag is always recommended in every service that you create because later on it plays a major role. But right now I'm not going to do any additional configuration over here. We are just going to create a simple Lambda function. I'll click on create function and let's see what all comes into picture. So it will take few seconds for the Lambda function to be created. So guys, as you can see, our Lambda function is created. So I will just dismiss this, and this is our Lambda function. It is still loading the basic code that we have. Now, what is been created over here? So this is our Lambda function that got created, and there is no layers. That's why it is showing layers as 0. Now, if I want to add a trigger, for example, if I click on add trigger, see it is going to show me the different trigger that are been available by using which I can invoke Lambda. See, now if I go back to Lambda, I will cancel this, and once I perform the trigger, I can also add the destination on which it has to make changes or do any association. So these are console level changes also that you can do. So this is in the diagrammatic format, and if you want, you can see that in the template format too. Over here, that is a SAM template. And if you want to make any configuration, you can do that accordingly in SAM template too. But this is the, I would say, advanced part. So we will just focus on the basic structure right now. So once Lambda is created, what all things comes into picture? The first thing is it created a sample code, but if you want, you can change the code. So when you get the sample code, you can go ahead and test and run to see what output it gives. But before we run, let me drive you through what exactly we have. So to run this, I am going to click on test, and I will create test event. So I will say test event 1. Okay. And it can be private or shareable. If I make it private, it is only going to be available to this specific Lambda. It says this event only available in the Lambda console to the event creator, to me. But if I use shareable, it is going to be available to the IAM resources within the same account who have permission to access shareable events. So if you're working as a team, at that time it is useful. So I will go ahead and save this. So once my event is been saved, what I am going to show you is, if you see the menu bar over here, this has different options. Now if I click on test, it is going to show that if we have already created any test or not. So you can create a new test, or you can or it will display any existing text. So this is the test event that I had already created. So now when you have a test event, you can click on test, and it has ran your Lambda function, and here is the output that is over here. So it is showing the status that the Lambda was run successfully, the name of the test event that we gave, and the response body. So this is the return response body which came into picture. So right now it has only printed the response, but if you want, when you run this Lambda function, you can also go ahead and give the print statement, which would say first Lambda function. But now you will see when I click on test again, okay, this is not getting printed. What's the reason? The reason for that is I have not deployed my changes. So for the first time when you run it, it is okay. But next time, whenever you're making any changes, you have to click on deploy. So once your changes are been deployed, after that, see, it is saying updated. Now the update is done. Now if I go ahead and run it again, you will see my print statement is also going to be over here. Okay, I'm clicking on test again, and you will see our print statement is also available as part of the code that we ran right away, first Lambda function. Okay, so this is how you can use your Lambda function, create your Lambda function. So these are the basics of creating Lambda function. So now once your Lambda function is created, I showed you different things, like this is the runtime that we selected, that is Python 3.12. This is the Lambda handler that we have, Lambda function underscore Lambda handler. If you have to change it, you can go ahead and do the edit over here. If you have to add a layer, you can add a layer over here. And these are the further information for encryption, KMS keys and all. Now let's understand, uh, if you want to monitor the what action has been performed as part of your Lambda function, you have a monitor tab over here by which you can monitor it, because by default, as I said, the role is going to provide permission to Amazon CloudWatch. So after some time, when it has a lot of data, it is going to start reflecting over here, but it is going to show you the invocation, the duration of your Lambda functions, how much time it is running, any error is encountered or not, everything, any throttles, concurrent executions of your Lambda functions. Suppose if I'm going to get one API a request, at that time one Lambda function is running. Now when I get 10 API requests at the same time, it is going to run 10 different uh, Lambda functions concurrently to perform the task, right? Now, if you go to configuration, in configuration, you will see all the configurations. Suppose if you have attached a trigger, the trigger is going to be available over here. Suppose if you have attached any permissions, so by default, this is the permission which comes from the IAM role, which we created by default with the Lambda function, which is showing that you have these all permissions. What are these permissions? It is all for AWS CloudWatch logs, and these are the resources which are been associated, and these are the actions which are there. We have not attached any resource based policy statements, so it is not available over here. Now, as I said, destination also we have not added, so it is not available. Function URL we have not. Environment variables, if you want, you can edit and add your environment variables. Tags, if you have not added that while creating a Lambda functions, you can. If you have associated this to a specific VPC, it is going to show here. If not, you can go ahead and edit and associate that. If you have connected your function to a RDS database, it is going to show the RDS database connections over here. And concurrency and recursion, code signing, file system, and state machines. So these are all the advanced topics that I have not covered as part of PPT, so I won't be talking. So this is how you go ahead and create your Lambda function. Now let's do one exercise to understand how Lambda function works and what is the benefit of it. So what I'm going to do is I'm going to go ahead and create a table in DynamoDB. The table name is going to be users. So where is tables? Or I can go to the dashboard itself and say create table. So it is going to be users. Partition key can be user ID, and so partition key we are going to keep as user underscore ID, which is going to be a string by default. It should not be an issue. And when I go ahead, I'm going to use default settings. When it is done, we can go ahead and create our table. Once our table is created, I'm going to click on this, and okay, instead of that, I will go to explore items, click on our table over here, and I'm going to create an item. Over here, I'm going to use JSON view. If you are watching this video before watching my last video for DynamoDB, you might not correlate, but you should watch the previous video where I have showed that how you can create table items by using JSON over here. So that is what I'm doing. So I am going to create multiple items inside the user table that we have created. So I will just click on create item. One item is created. In the same way, I am going to create multiple items. So I will go to JSON and paste. Second item is created. Now third item, create item, JSON view, and third item is created. Now my user table is having three different items from 1 to 3. Okay, and this item is having user details. So once my item has been created, I am going to go back to my Lambda. Now once I go back to my Lambda, what I have to do is, so once our DynamoDB is created, our next step is going to be to add a code over here, that is this. Now let me explain you what exactly the code is. So in this code, we are using Boto3. By inside this Boto3, you will see I have used Boto3 function in which I am using users. This is the user of our DynamoDB. So what it is doing is it is going to run this method. By running this method, then it is going to perform a table scan. Once it perform a table scan, it is going to get all the items available inside the DynamoDB table, and it is going to add that as part of the items over here, that is the items object. Once this item is added into the item object, then we are going to go ahead and return those items as part of it. Now while doing this operation, if there is any error, we are going to go ahead and print the status code as 500. If it is going to be successful, this code as part of try, it is going to give us the status code as 200. If it is going to error out, it is going to give us the status code as 500. Now after changing the code over here, do you think it is going to run? Actually, it is not going to run. The reason for that is I have to go ahead and update the permission, because right now it is only have permission to talk with CloudWatch, not with DynamoDB. So to do that, I have to go to configuration. Okay, I will go to configuration. Once I am in configuration, I have to go to permissions. Inside this permission, I will have to click on role name. Once I click on role name, it has taken me to that role. So right now, just for demo purpose, what I'm going to do is I am going to just add a permission over here, which is going to be not least privilege. So just bear with that, because if I go ahead and create, it is going to take a long time. So I will just click on attach policy, and I will say DynamoDB full access. Okay, add permission. Now permission is been added successfully to my role. Now over here, it is not going, if I will try to reload this and to see if it has given the permission. So yes, you can see that now it has given multiple permissions, because we added DynamoDB. Apart from CloudWatch, it has further permissions now. Now before testing our code, what we will have to do is we'll go back to our code. Our new code is the new changes. So without deploying it, it is not going to run. So I will deploy the code, and it will give me a pop-up that the code has been deployed successfully. So once our code is deployed successfully, we get the message. Then we have to go ahead and click on test. And this is saying it is loading, running, and this is the response. And guys, you can see as part of the response, it has returned all the three different users along with the IDs and all the details to us. And if I see it over here, it has returned the list of all, that is the fetched items that we have fetched as part of the code. And you will also see as our code was successful, it has given us 200. If it would have been an error, it would have given us 500. So this is how you can go ahead, run your Lambda functions, and this Lambda function can perform multiple operations. Right now we perform one of the operation, that is a get list, you can say, in which the Lambda function went to my DynamoDB. It scanned the table and fetched all the available items inside that DynamoDB and gave it back to me. Now once I have the item, I can use it for further processing or any other operations that I want to perform. Now let's get back to our next topic, that is Lambda limits and best practices. So talking about Lambda limits is very important because it has hard limits. So each Lambda can run for a maximum of 15 minutes and use up to 10 GB of memory, and have a deployment package size of up to 250 MB only when using layers and dependency that I showed you already on the console. So by default, each AWS region supports 1000 concurrent execution, but you can request an increase through AWS support if workload needs more. So by default, it is going to be 1000 and it keeps on changing. Maybe now at this time I am saying you that it is 1000. Next year in 2026 it would be 2000. So it keeps on changing. So always cross-check these kinds of information that I am providing you in the official documentation. I am providing it from the time when I had made this PPT for you. Now, to reduce the cold starts, keep your functions small and lightweight for critical APIs, and enable provision concurrency so your function is always warm and ready to respond instantly. What does that mean? As I said you, when you are going to create your function, if your function is going to take a lot of time, first time it is going to have a cold start, right? At that time it is going to take a long time. So keep your code short and crisp. From a security perspective, never hard code credential inside your code. This is a best practice that you have to follow. Instead, if you have any credentials like database credentials or something, you can store them securely in environment variables. So if I go back to the console, I told you, right, in under configuration you have environment variables. Over here what you can do is click on edit, and over here when you click on add environment variable, so see there is an option over here, default. So this is the encryption, and you can add, it will be encrypted over here. So your key value pairs is going to be safe instead of hard coding them into the code. That is one thing. And second is AWS Secret Manager. So you can also give the invocation link of Secret Manager, so from where it can go and get the password for your specific database or any other resource which require a password. Now, finally, from the monitoring perspective, always enable CloudWatch log. So by default, execution role is there, but many a times when you're going to create your own role, don't forget to enable the CloudWatch log, because if you're not going to enable the CloudWatch log, so the monitor over here, see now maybe it has some data, so it might come up with some details over here. So it is showing one, I will make it as 1 hour, and you will see some details have started popping up, that the count of lambdas one. So I have made 2 invocation of the lambda that I have created. Then over here you can see the milliseconds in which it ran, right? See, it is showing minimum, maximum, all the details over here. So error counts, we didn't had any errors. So was there any throttle or not, any concurrent execution? So it's very important for you to make sure that you have given the CloudWatch permissions so that it is going to run seamlessly. That is one aspect. Another aspect is when you set up CloudWatch alarms, you can also get notified about errors or high latency. For example, suppose if your Lambda times out, it didn't run at that time, if your CloudWatch is enabled, it is going to log that event onto CloudWatch, and based on that you're going to get notification. If you don't enable it, you're not going to get. So following these best practices will help you maintain fast, secure, and production ready Lambda functions. And thank you for watching. I hope this session helped you clearly understand how AWS Lambda function works, from setup to scaling, and the most important part is the best practices. If you find it useful, don't forget to like, share, and subscribe for more AWS tutorials like this, and see you in the next video.